All right. I think we're going to go ahead and get started here pretty soon. Good morning, everyone. Welcome to the first breakout session of the day. My name is Nick Herrig, and I work at Principal and have been for the past 2 years in IT operations.
My name is Matt Ring. I also work at Principal. I'm an Agile and technical coach. So I work with teams, both software delivery teams and infrastructure teams, helping them apply Agile, Lean, and engineering practices to make their lives better.
And today we're going to talk a little bit about the bottleneck effect. And by the end of this presentation, and come Monday, hopefully you all have all the tools that you need to start improving delivery flow by using value stream mapping activities. Also, see a lot of Principal folks up here, so sorry if we do any spraying or anything, so watch out for that.
All
right.
I appreciate all of those who have already eaten the fruit rather than waiting for it to get thrown.
So before we get started here and jumping into one of the many tools that you can use to start improving delivery flow in your organizations, wanted to kind of pay tribute to a really awesome company that really we wouldn't even be talking about Lean if it wasn't for Toyota, a manufacturing company. And before I really started learning about Lean in school and through reading other books, I always thought Toyota was this like perfect company that they, never really made any mistakes or messed up, and that they really just kind of started great. But it wasn't until about 2 weeks ago that I was listening to a presentation by a really awesome guy named Steven Spears, and he had this really great keynote at a DevOps summit a while back, and he's kind of talked about one of Toyota's big failures. So does anyone know what that car is in the top right there? I'm going to bring that up. Does anyone? No, shout it out. No, it's called the Toyo Pet, and there's probably a pretty good reason why you don't know or have heard of that vehicle. Because it's a pretty special vehicle. It was one of Toyota's largest failures, and it was honestly just a really big flop by Toyota as a company. One of the crazy things about this car was that it was Toyota's first attempt at selling a car in the American marketplace. And essentially it was designed for Japan's roads at the time, and whenever you'd get it above 60 miles an hour, the steering wheel would really shake, and the rear view mirror would shake, and people were afraid that even get from point A to point B in it. Also, a fun fact about the Toyo Pet, you had a higher probability of getting up a hill driving it in reverse. So, which was also pretty funny at the time because the first place they introduced the car was in California. So pretty brutal move there. Another thing, there are salespeople that were quoted on saying, "I just can't sell this thing. It's a piece of crap. It's unreliable and it's too expensive." And when have you ever heard a salesperson say that about the product they're selling? So they decided to pull this car out of the United States market, but also while they were kind of looking at some of these lean practices and starting to improve some of the systems around them. And at that time, after they pulled it out of the market, their production was equal to that of the world standard. But really, I'll take a step back here really quick. One thing about the kind of crappy Toyo Pet, at the time that they were manufacturing it, it took 7 more people to make that crappy car than the world standard. So Ford was putting out cars with 1 person. The Toyo Pet was being put out with 8 people. So they pulled out that production. They started working on these lean tools, and they essentially came back in the early to mid 1960s and introduced a new line of cars, a new arsenal of cars there. And they started really capturing market share. And the thing about these new cars was they were reliable, they were compact, and really they solved customers' problems that they didn't even know really existed. And then looking even later on, they improved their productivity to twice that of the world standard. So how did they kind of go through this transformational change? What we kind of, and what Steven Spear kind of mentioned was, it was the Toyota production system. That's what it was branded as. But essentially, they were just aggressively seeking out problems in their organization and using Japanese method tools to seek out some of those problems. So the 3 things that they were really trying to solve here was reducing their excess inventory, improving their throughput, and implementing quality checks throughout the system so that rework wasn't really taking place. And all of that really equated to increasing their operating earnings and helping solve customers' problems. So you may be thinking, and I know like when I first started at Principal and working in IT, and my background's originally in manufacturing engineering, I kind of was thinking, how does this actually relate though to the IT space and into software delivery? Like, right? Like most of us all work in tech companies. But there were a lot of areas that kind of transfer over that we can start to take into our everyday. If you've read the DevOps Handbook by Gene Kim, he kind of brings this out as the first flow. And some of these processes that kind of correlate are making work visible. Now, on a manufacturing floor, that's a little bit easier, right? You can walk up to a machine on a manufacturing floor. You can actually see the product. You can see the car going through the line. But a lot of the work that we do is invisible, right? So using things like, essentially like planning boards to help visualize that work, so Kanban boards. Along with that, look to limit the work in progress as well and reduce batch sizes. Another thing that we can work to do is reduce the number of handoffs throughout our systems. So if you think about large projects that span multiple teams, things like building out new platform services or working with ISR or your security teams to move through different teams, that's another area. And one of the big ones is eliminating waste in the value stream. We heard through a talk with Marty yesterday of the different types of wastes in our value stream. And here are just some of those wastes and how they relate to the software engineering space. So partially done work is a big one. Extra features that maybe our customers don't even need. Relearning, usually due to some sort of like task switching. Delays in our process, and defects. But how does this look in our organizations? And so Matt's going to tell us a little bit of the story here throughout an organization.
Story time. Okay. Somebody asked beforehand. They're like, all right, so all the talks I've been to, they ripped on somebody. Well, who are you going to rip on? Oh, we're going to rip on. Okay. All right. So let's start with, we talked about, waste and how lean applies to software development, but I wanted to kind of give a story here to more kind of show, don't tell. So, as all great stories, it started on a Monday. So, this is Devin. Meet Devin. Hi, Devin. How you doing? Devin's a developer. He's on a software delivery team. And he came up with this idea. So, the team that he's on is basically, they maintain a customer-facing web application that's responsible for product sales for their organization. And so, like a lot of good ideas, they don't just come from the product owner or product management or the marketing team, they also come from within the team. So Devin has this great idea that he thinks is going to improve the customer experience. If they tweak one little thing to the experience, he thinks that by doing this, they'll actually increase their product conversion rates. They'll sell more product. So comes up with this, he got an idea, comes up with this Monday night. He's all about work-life balance. He doesn't want to just go ahead and start on this thing, so he's going to wait until he talks to the product owner and the team tomorrow, make sure it's good. All right. Okay. Keep it. All right. So Tuesday morning rolls around, 8:45 stand up. Devin gets together with the team. Stacy, the product owner, is there. She's got a cup of coffee. Devin's like, hey, what if we did this thing? Stacy's like, hey, that sounds great. And because we're such a great team, we actually have some extra capacity in this sprint. And you said it's a really small feature, right? So let's just go ahead and do that thing. Because I'm empowered to do that. Devin's like, I could have this thing deployed by this afternoon. It's like a few hours worth of work. Oh, Devin. Okay. So true to his word, Devin sequesters himself for a couple hours. He hammers out this feature. The team is they got trunk-based development, they got short-lived branches. So he branches off the master, does all this stuff locally. Everything looks great. 11 o'clock, he's got it all hammered out. Local testing looks great. 11 o'clock rolls around. I submitted the pull request. Where's Phil? Phil is the tech lead, and he missed the stand-up this morning, so he doesn't have any awareness of this is happening. Also, the team working agreement, they've had some problems in the past, so all pull requests that go to master have to get reviewed by the tech lead. So, unfortunately, Phil missed the stand-up, but he's also in meetings all morning. So he's supposed to be done according to the calendar. He's supposed to be ready to go at 12, back at his desk by 12:30. So, true to the outlook. Phil's back at his desk by 12:30, gets his sandwich ready. He's like, oh, I'm so hungry. Devin disrupts him. He's like, hey, I got this PR I need to get submitted. You're ready to go. It's this great thing. Bill's just like, whatever. Rubber stamps it. Sure, why not? Looks great. All right. Devin merges it to master. Solve 40. Bill breaks. Devin's like, what? It worked on my machine. What happened? All right. So 10 minutes worth of build logs later, going through and figure out what failed. Devin reviews it, determines that the dependent libraries are missing from the build agent, and he needs to contact the DevOps team. Complete with Kate. All right, DevOps team, I'm happy to help, citizen. Where's your JIRA ticket? You see, now it's starting to resonate with people, right? Okay. All right. So this is 1250. Devin submits the JIRA tickets. It's usually all the things I need. I just need to install it on the build agent, and I'm ready to go. DevOps team's like, got it. 3:45 rolls around. Finally, DevOps team loads back in. They come in, they say, hey, we installed it on the this dependent library on the agent. Also, here's the time we're going to lecture you on the values and virtues of artifact repositories and why you should care about these. And then you don't have a dependency on the build agent. Devin's like, yeah, that's great and all, but it's a legacy dependency. I get a giant noise. DevOps team's like, oh, I'm so sorry. Shoots away. All right, 4:15, build succeeds. Devin's like, boom, ready to go. We got our CD pipeline, we deployed to test. Everything looks great. Functional tests are passing. We do a little bit of exploratory testing. All that stuff's great. 4:45, ready to deploy to the next environment. UAT environment, we can't deploy because we have an approval gate, and our product owner has to approve that. Unfortunately, Stacy's already left for the day because it's 4:45. Devin is crushed. He won't meet his commitment. All right, but that's okay because we're going to meet with the team on day 2. Day 2 rolls around, 8:45 stand up. Devin's like, hey, let's do this. It's ready to go to UAT. Stacy's like, I'm on it. 9:15, we deploy it to UAT. It breaks in UAT. Devin's like, why did it work in test? Why is it deploying in UAT? Why is it failing in UAT? Well, now I got to contact the platform hosting team. Hi, this is Pete from the platform team. He's got his on-call phone. He always seems on edge, like something, like the next thing's going to break or whatever. So Pete's like, where's your JIRA ticket? What's the severity? Devin's like, it's not a production issue, but it's still important. All right, so Pete digs in, spends a couple hours figuring it out, trying to troubleshoot it, comparing the different environments, configurations, all this stuff. Finally determines that platform is fine. It's a database issue, not it. You need to go contact the DBA team. All right, so Devin's like, fine. So Abby is the DBA lead. Abby, I got this issue. I submitted the JIRA ticket. Here's the problem. It's an issue happening in UAT. What's the deal? Abby's like, oh, I see you got a JIRA ticket. We use ServiceNow. Can you submit a ServiceNow ticket for us? I hope those are still happy tears at this point. And not okay. All right. So Devin submits a ServiceNow ticket. But the database SME that's most familiar with this, subject matter expert, Brent, who's the subject matter expert, he's left for lunch. Devin's like, all right, well, I submitted the ticket. It's in his queue, so he's sure he's going to look at it after lunch, right? 4 o'clock rolls around. Devin's like, I can't get a hold of Brent. He's nowhere to be found. Abby, what's the deal? Abby's like, oh, I'm sorry. Brent was actually pulled into a production issue all afternoon. I'm sorry about that. It was really important stuff. But he promises he'll look at it tomorrow morning because he says it's like 5 minutes worth of work. Day 3. Devin gets to a stand-up meeting. Everyone's like, is it going to be today? Devin's like, well, it's got to be, right? All right. Stacy's like, good enough for me. So Stacy's got kind of the approval from Devin, like confirmation. So Stacy goes and talks to Dan, who's the business leader. Says, hey, just so you know, we have this idea on the team. Just a heads up before we roll to production. We're going to roll this thing out to production this afternoon. So just a heads up that we're expecting this to have a positive impact on our customers. Dan's like, wow, this agile stuff really works. You're so responsive. Kudos to Pete, by the way, for that. I just totally stole that capitalization from Pete. That was good. All right. Back to 9:15. Devin's like, all right, I worked with Brent, the database scheme is applied, the UAT environment is working again, all the exploratory testing, the functional testing, all that stuff is working great. That was like, Excelsior. All right, 9:30, submits the change request for ServiceNow, coordinates the database changes with Brent, because we all know that when we're cross-team dependency, it happens that smoothly. Everything else, whatever, but all right, but we're ready to go to production. Everything's good, we submit it, just needs to get approval. 9:45, it goes to Kurt, the HR leader, who has had no context at all for anything that has been happening for the last 3 days. What's more, Kurt is where a lot of leaders provide the most value in meetings. But he promises to look at it as soon as he can. 12 o'clock rolls around, takes a look at the ServiceNow ticket. He's back from his meetings. And what we can only surmise is that Kurt, through several years of experience plus strong leadership prowess, is able to look at that change ticket and determine the appropriate risk level for this and whether it should go forward. Approved. Awesome. 12:45, we deploy it to production. It was totally awesome. All tests passed. It's great. It's in production. Customers are using it. Devin's like, totally worth it. And then Devin, at 12:45, Devin decides he's going to take the rest of the day off. Because that's what software delivery teams do. They deploy, and then they leave and go get a beer. Told you. We're going to hit on speed. All right, here's the kicker. Day 4 rolls around. Daily stand-up. Dan, the business leader, shows up, which seems odd. Dan actually says that new feature that they just deployed yesterday is actually having a really negative impact on the customers. And we really need to roll that thing out of production right away. Dan says, hey, you're agile. Let's just get this thing done by noon. All right. So, what can we learn from that? All right. So, the takeaways from that, basically, is that a lot of companies, a lot of organizations, what they do is they see these inefficiencies and really chase the symptoms. And then we use a lot of our own conventional thinking to figure out, like, how are we going to solve that? Things like, we need more people. Let's just throw more people at the problem and be fine. Or, because we're at a DevOps conference with full stack teams is the thing, right? So if we just had everybody that we need just on that team, we would be completely top optimal and efficient, right? But what we showed in that example is that they even had handoffs within the team and delays happening there. So just throwing more people or creating full stack teams in itself is not going to address the issue. We need better tools. If we just got rid of all of our legacy stack or these big monolithic environments, we could, if we just containerize and microservices the shit out of everything, then everything would be great. But we also know that doesn't necessarily happen. If you've been in the industry long enough, you replace an old technology with a new technology. It may solve old problems, but it creates new problems, right? And sometimes those new problems are even more complicated than the other ones. So again, replacing tool X with tool Y, again, is not just going to solve the problem. We need more discipline and attention to detail. So like, if people just sat all day and just watched the cues, they'd be ultra responsive, right? If they didn't do anything else but just watch the cues. Well, we know that's not sustainable. And really, most people don't derive satisfaction from going to work and just watching cues all day. And as leaders, we really don't want to be paying our top talent to sit and do that when they could actually be going and refocused and solving real customer problems. Where are you going? Yay, animation. Lastly, we'll just wait and see what Gene Kim does. Oh, never mind. That one didn't land. All right, that's okay. We got more. All right, so if we can't use this conventional thinking, how can we instead apply lean concepts and lean practices to help us discover what's truly slowing down the flow of work? So, Nick, how can we do it?
Let's take a little bit of a look at value stream mapping exercises. So this is just one tool in the toolbox, and one tool that really encompasses lean thinking. But essentially, it's a process that we'll kind of go through over the next couple of slides. But essentially, what it allows you to do is visualize, analyze, and improve the flow of value through your system. Really interesting thing about value stream maps is that it allows you to find and then focus on eliminating waste at your constraints and your bottlenecks. So we'll go over a little bit later why that's extremely important to focus on your constraints and your bottlenecks and that weakest link in the chain. And then we'll also capture our current state. We'll start to talk a little bit about some of those metrics that are really important when gathering and conducting value stream mapping exercises. The really important thing to note here is that it's the current state. We're not going to go and conduct a value stream map and take a look at, where we might be in 5 days. We're going to take a look at where we are today, be extremely honest about that, and work towards solving some of those problems and looking at some of these metrics. So speaking of metrics, I'm going to talk a little bit about capturing those value stream mapping metrics. One of the most important metric, and also really important to understand what it is the lead time. Now what the lead time is it's your total time from when work enters the system to when that value is delivered. So that also includes things like waste, but it's just the total time. So in an IT scenario, right, it might be that time where a ticket actually enters the system and then that value is completed. Now, part of the lead time consists of that value added time, which is also referenced as process time. So those are synonyms there, but it's the total time spent actually working on that activity. So one important thing to note here, and is this can be kind of a tricky one, like what does value added mean? It's like in manufacturing, it's really easy to see, right? When we're adding or removing material, that's considered value. But in an IT space, that's a little bit more challenging to see. What I like to think about it is when we actually have hands-on keyboards or hands-on mice. And then one of the most overlooked metric is the work percentage complete and accurate. This is extremely important. How many people have received a piece of work back just to find out that it's broken or that it is not working, and you have to go and find, maybe what part of the process is the broken part? So this is just the proportion of work that is typically done right the very first time, and it requires little to no rework.
Okay, so what I wanted to do is just take a few minutes and talk through a few example value stream maps that we've done at Principal, just to give you a flavor of this. So I'll give this without going into too many details here, but so the first example, we didn't do a value stream map, but the story we talked about the software delivery team and what the pipeline would be for delivering piece of software, and you kind of identified some waste there. We have a couple other examples of shared services type of request fulfillment or process ticket type of requests there, as well as some infrastructure stuff. All right, so this first one was an early example. The idea here was basically, so in our company we have processes in place when we have like open source software or new technologies. We want some level of review or some level of governance just to make sure we're not just pulling something that might be a risk in and affecting our customers. So we have a process in place to kind of review that with our security folks. So what I wanted to do here was basically I had a situation come up where I needed to review that. So what I did was I ended up just following that piece of work through the process. And every time there was an activity, I captured that activity. So each of those sticky notes is basically one activity that happened. And what I did, this was an early example. So what I was capturing was basically 2 of the 3 metrics we just talked about. So the process time, so how much time actually was spent doing the work, as well as the wait time. So how much time was work actually just sitting in a queue, waiting for something. And so from doing this, so after doing this, I basically captured it from my perspective. And then I went back and circled back with the other teams that were involved in this to understand from their perspective. It's also extremely important to get all of those perspectives, to understand how much time they spent on their activities, what activities they did, how much time work was sitting in their activities. The findings were actually pretty interesting. Interesting is such a not even the right word. Okay, so the total lead time it took for this piece of software was 28 working days. So this process to say, all right, is this software appropriate to use for our company? For 28 days to review that and get that all clear that we were okay to do that. So about a month. The total process time, the time it actually took to do the work, was 14 hours. That's less than 2 days of actual time. The other thing I noticed was work handed off a bunch. Work was handed off 8 different times in that process across 3 people. So you get it, get back, you get it, you get it, and then 2 more. I had to get 2 more. So the percent of time spent on actual value add work, which is basically the process time divided by the lead time, was 6%. So this was a 6% efficient process. This led to some really great conversation. All right, so that was one. Another one we did is more of an infrastructure example. So any infrastructure folks? Anybody deal with like virtual servers or actual hardware? Anybody deal with actual hardware? A few. All right, awesome. All right, most everything's virtualized. So this is an example we did. So we have our own data center, and so for a lot of folks within our organization, everything's virtualized and spins stuff up as we need to, whatever. But we have a subset of group that also says, well, no, there is actual hardware that runs behind all that stuff. So we need to do something with that. So what we ended up doing here was we basically did a value stream map that was cross-team. And we walked through what it would take basically to kind of, if they need to scale out that data center or if they need to cycle out some servers, some old stuff. And we wanted to figure out, like, what does that process actually take? How long does it take? How involved is that? This is actually a pretty involved exercise. What we ended up doing in this example was we color-coded the different teams. So you could visualize where certain teams had a bulk of work or where different handoffs occurred. The other thing we were dealing with was because this was actual hardware and not servers, we were time bound, or we had some external constraints of what we could do it by like actual hardware shipping to our data centers. And it'd be like if you had Amazon Prime and you were like, I want to ship this thing, but I don't want to wait 2 days. I want it to done in an hour. You're kind of, unless you have an in or you're on the early adopter drone, you're kind of limited to that 2 days. Same type of thing for us. So what we did was we mapped out the process. We kind of at a macro level figured out about how long different things took. And from doing this, we didn't really find anywhere that we were necessarily like just waiting on work. But what we did find was that third metric was the percent complete and accurate. What we found, and you can see it towards the back here, the focus bottleneck, this downstream activity, by the time we got to that activity, it was a 1 in 10 chance that everything was configured correctly by that point. 9 times out of 10, something upstream had gotten misconfigured. And usually what that meant was that yellow team couldn't solve that themselves. They had to pull in another team to do that. So we were having to get rework happening involved there. So that allowed us to say, all right, well, there's a bottleneck there because it's got a low percentage complete. Now, what is upstream that is contributing to that? And that really helped us focus our conversation about where to go. So those are just a couple of examples that we've had here. So as you go through this, potential question might be, well, I'm doing this for the first time. I'm seeing all sorts of waste. So where do I start? So our argument that we want to do is resist the temptation to resist the temptation to play improvement whack-a-mole. Instead, focus on the biggest constraint. Why do we care about the biggest constraint?
We're going to talk a little bit now about queuing theory. See a couple people in the back getting up and leaving, actually. Queuing. Yeah, so maybe we'll frame this as theory of constraints. So there's this really great book by Dr. Goldratt called The Goal. If anyone's ever read that, it kind of talks about kind of the manufacturing processes and that really focusing on the theory of constraint and this ideology there. But one of the interesting stories from that book, it's kind of a funny one. He takes his children on a hike, and he starts and so there's this big group of Boy Scouts going through a hike, and he realizes the group keeps getting separated. And he starts to realize, like, why does the group keep getting separated? Well, there's this really cute fat kid named Herbie, and he's just slower than everyone else because that his capacity to hike with everyone else was just slower. So he started getting some ideas, and that really brought up the theory of constraints. So let's say we have a system here. This system could be 4 children hiking. It could be a manufacturing process. It could also be a process that delivers value throughout your value stream. Each one of these processes have some sort of capacity. So in this example, 3 of the 4 steps there have a capacity to deliver 5 pieces of value per day. And the third there has a capacity of 2, which is our bottleneck. So obviously, because we have this system that has capacity, delivers value, there's obviously a demand for that, right? So we're going to provide this system with some demand. And as you can see, as we fill that demand, we realize that the pieces of value go through our system. But we start to realize once we reach that bottleneck, we start to queue up. Has anyone done work from a ticketing system, or does anyone here have a pretty large backlog of projects? That would probably indicate something interesting there about a bottleneck. Now, one of the most interesting pieces about this is after the bottleneck, because we only have a capacity to complete 2 pieces of value there per day, we're only passing 2 pieces of value to work on from the next stages as well there. So that creates a little bit there. So we have value going through the system, but as we continue this process, as we notice, value will continue to pile up at the bottleneck there. And it's really easy to see in the manufacturing process, right? You walk out to the paint line and there's a huge stack of parts here. It's like, oh, well, obviously your paint line's the bottleneck. That could be a little bit more challenging in IT. Now, Matt also mentioned the idea of rework as well. So imagine now if you're sitting at that stage 4 and you have a defective piece of work there. Not only do you decrease the amount of value that you're putting through your system, most likely you have to figure out at what stage that defect took place. So that also is just the effects of rework. But really, what we wanted to get out of that example there is the illusion of local optimization that we find so much at large companies and where there's siloed teams. That any improvement made anywhere besides the bottleneck are illusions. So a quick example of that, let's say we're on a team here where we are in front of the bottleneck and we say, you know what, we're really gung-ho about improving our processes. We want to add some capacity to our team, right? Well, for this specific piece of system that we're pulling through work, we're going to create capacity for our team, sure, but we're not going to actually deliver any value for that particular value stream any faster because we're limited by our bottleneck. So maybe we'll play a little bit more ping pong during the day or go rock climbing early. I don't know, something like that. But the next piece here is let's say we're come before the bottleneck of our process and we're really gung ho. We want to solve our problem. Well, what we're going to do there is increase the velocity and increase the width of the entire system. So we're going to see that value we're going to see that work in progress builds up even faster at the bottleneck because of that throughput. It's really the 2 points here. Improvements made after the bottleneck will remain starved of work, and improvements made before the bottleneck will just result in increased width. So that's why it's really important to focus on those constraints.
All right, so talking real quick about workshops. So we introduced value stream mapping. You've seen a few examples of it. So if this is something that you're interested in, you're like, well, how do I do this back to my organization? So a couple little suggestions for you here. All right, so the first one, when you're conducting a value stream map workshop, don't leave anyone out. I think not anyone, but really. So the focus here is to include anyone and everyone that contributes to that overall value stream. Everyone is needed who touches that piece of work to be able to make sure that you're accurately documenting reality. So a common misguided attempt sometimes is, I don't know if we're leaders on the bus, but leaders or scrum masters or architects who are like, well, I sort of know it. I'm pretty good to know what's happening here. I'm going to protect the team's time and I'm going to go ahead and represent them. Because they got cues. They got cues they got to watch. So the problem with that is that more often than not, those folks, they think they have a good understanding of how the work's actually getting done, but they're not as accurate they're not as informed as they truly are. So it's really important to make sure that the team members that are actually doing the work are involved in the workshop to be able to accurately portray what's happening. If it's an issue getting all the people together for something like this, food is always a great motivator. So buy lunch, bring breakfast in. If you don't have a budget, go find a leader who does have a budget and ask them to buy it. But again, do what you need to do to be able to get everyone into there to be able to collaborate on this thing. So I said team members are very important to have it. Leaders do play a key role in there. A lot of it's really around like the enablement. And I don't mean that like empowerment, like I empower you to do things, just go for it. But really, it's enabling the teams to have time to dedicate to do this value stream mapping, to do these workshops, as well as to problem solve, like how would we improve this, and afterwards, once they have figured out what they want to do, giving them the opportunity and the breadth to be able to apply those to those improvements. Yes. So the question is, do we do it before we do a process or an existing process? Yep. Yeah, so what I'll say from my experience is this is still, it's fairly new. We have other folks probably in the organization who've done this a bit more. We probably do more kind of the new process. My experience has typically been existing processes. So we're taking existing processes and saying, all right, where do we have waste and how can we improve existing versus how do we do it? How do we optimize the program? Good question. There we go. Okay. So the other thing, a potential format for a VSM workshop. This was taken from Courtney Kistler, who did a course, an online course, DevOps Culture and Mindset. She's the VP at Nike, Digital Platform Engineering. She's previously worked at Starbucks and at Nordstrom. She's a co-organizer of the DevOps Enterprise Summit. But basically, she came up with she presented a format here. So the first thing is really, once you get people involved, spend a few minutes right at the beginning just to create that shared understanding of what Lean is, how it applies to software delivery. It could be just as simple as some of the things that we just talked about, is like, here's what value stream mapping is, here's what it looks like, here's the metrics that we are kind of caring about, and then let's go forward. Just again, so everyone kind of has a baseline understanding. Second one, identify the problem or set of problems that you're actually trying to solve, or potentially the desired outcomes. So examples might be, it just takes too long for us to deliver stuff. We want to decrease that. We want to increase the throughput of being able to deliver stuff. We have defects all the time. We want to be able to reduce the number of defects that we roll out to production. But identifying what those problems are that you're trying to solve. Third, document that current state, that step-by-step process to ship a typical feature or to deliver a piece of value. The fourth one, once you've got that process flow out there, the team goes back and they estimate, and they provide estimates for how long each step takes. And so in that case, we're capturing, again, kind of the wait time, how much time work is sitting in a queue, process time, as well as what that percent complete and accurate is. If you've got actual data and systems, that's always great. But at this point, we're kind of looking for just give us a good estimate at this point so we can start to do that. And then what we might have teams do is, once after they provide that estimate, they may have underlying systems that they can go back through and see like how close were we to this type of stuff. The fifth one, so once you capture the current state, the fifth one is actually documenting that future state. So what is the future state of this process that would look like to get to those desired outcomes that we would want? And often this involves removing steps, reducing that total wait time, looking for where work is just sitting around. Let's see where it's at. Oh no, he still has some. Okay. Example I've seen recently that I thought was a really great idea is this idea. So we talk about pairing, like pair coding, pair programming, or different things like that. We even paired infrastructure type of stuff, but pair facilitating actually is a really useful thing here too. So this is an example where we had a recent exercise, and what these guys are doing is we've got one person on the right here who's basically leading the discussion. So he's eliciting feedback from the team. All right, explain to me what's next in the process. Okay, what happens after this? Asking those questions, and the other two folks are actually kind of transcribing what's being said and providing that on the wall here. So it allows the facilitators to kind of have to separate duties and make sure that we're providing value. We're having an effective conversation there. Another variation that I've tried, if I'm doing it solo, is I will delegate some of those activities out to the people that are actually doing the work. So I'll give everyone sticky notes, and then when they're talking about their activities, I just have them write it in their own words what their activity is, and then I say, all right, let's go up and put it on the wall here. So that allows them to be engaged more effectively than just kind of sitting there and answering questions. Important to enable psychological safety. Participants definitely may feel defensive, especially as we start to dig into processes that are inefficient, especially if the work that they do is the biggest bottleneck. So it's important to promote that environment where people feel comfortable talking about these as much as possible. And this really is kind of facilitator, but also the participants as well, is to enable that judgment-free zone where it's here to attack the process, not to attack people. Measure impacts along the way. So again, if your focus is on decreasing lead time or increasing quality, make sure that you're measuring that stuff along the way. using charts like these or whatnot. It's also important that as you're making improvements to the process, that you're seeing if you're actually having the desired impact. So if you're wanting lead time to go down, you make a change and it actually goes up. That's fast feedback for you to say, okay, wait, let's pause. What did we actually change here that maybe had that unintended effect? So this is basically the lean concept: plan, do, check, act. Same type of thing as a retrospective. You plan what you're going to do, you do the thing, you check the results to see if it had the intended effect, and then you act on that new information. Lastly here, don't underestimate the time to improvement. So in our recent experience, we've done value stream maps. When we've done them that are in the 1 to 3 hour range for that format, typically we have just enough time to capture most, if not all, of the current state and potentially capture where the bottleneck is at. But we really don't have a lot of time to actually then go into the team and say, all right, how would we solve this problem? What would we change? What would our future state look like? And so teams, especially that are new to this, don't really know where to go from there. So it requires a bit of extra effort for our point. So don't underestimate the time to improvement in that initial workshop, especially, as well as the time that it's going to take to make improvements along the way. All right.
Sweet.
Where do we go?
So we're really going to talk now about maybe next steps, things that you might even be able to start doing Monday. So we're going to take the time to talk really quick about, maybe first developers, people who actually ship code, whether that's on a development team or whether that is, maybe even working in an operations or security role. So first, talk a little bit about that. And John Allspaw, well, really quick, how many people are developers or actually ship code production? Anyone? Couple. Sweet. So one item that John Allspaw recommends, and he was the past CTO of Etsy, and he helped really move Etsy's needle on the DevOps movement. But he mentioned doing just a comment commit and seeing how long, really just measuring the cycle time of pushing a change through, a comment change through to production. And really what people found there was, not only was it a low risk and easy change to make, but it allowed people to gain some experience and with value stream mapping without really like breaking anything or really having all their focus on that change. It also really energized the team to see where they could get their changes down to if it was such a simple change. So people were shown. One example, people saw that it took about 5 days to ship code, even though it was just a comment. But they were really able to focus on that piece. Now, how many leaders or leader of leaders or change agents do we have in the room? Great. So another example and some action items maybe from you all is to really start investing in the early adopters. A lot of these, and really know your early adopters and your innovators on your different teams. Really understand who those people are, so that, because usually those people are the ones who already are looking at trying to improve their systems. They're really wanting to try these new ideas and try to, and they're usually passionate about improving their systems. So I'll really try and influence that. Here's a nice little quote. Pretty obvious one, but also kind of powerful. You can do anything, but you can't do everything. So this is really our transition to just a quick review as we wrap up here, that it's really important to prioritize on some of the things we talked about. Things like focus where there's significant delay or those long lead times, really focusing on where there is a really low percentage of CA or your completed and accurate work. So really where there's bad quality, difficult quality there. And then also avoid the temptations of improvement whack-a-mole, really focusing on those constraints. So we did really stand on the shoulders of giants. There are a ton of different resources out there that not only we pulled from, but we learned from as well. So there's a ton of really great stuff, a ton of books out there, a lot of courses that we pulled from. If you're interested in any of that other information, our slides will also be online. Yep. Awesome.
Thanks, everybody.